Hi children, welcome to Euclid Learning. So this is the third part for grade 10 chapter 4. So if you haven't watched my previous videos, please go to the grade 10 textbook playlist and watch my videos from the beginning, because at least you start from chapter 4 videos, because this is kind of in the middle. In this video, we are basically talking about how to draw logical circuits and how to write the Boolean expression by looking at the circuit, those kind of things. And very importantly, as a practical knowledge, I'm explaining how to draw these circuits using software and how to test your truth tables and all. So sometimes it may be not very important for your real exam, because in the exam you don't have to do any practicals, but it's very good to have these knowledge in practical side also, because IT is a very practical subject. Not that you can just study and write an exam and get marks. You can get marks, but in the real life, it won't help you much, right? Okay. So before doing this chapter, actually, you should be very good at the previous parts we have done. So what we have done in those two videos for the chapter 4 is, like, I have introduced the logic gates for you. So we have done 3 basic logic gates, right? Hope you remember O and not gates, and we did 2 combinational logic gates like no and NAND, right? So if you are very comfortable with it, because you should know how the inputs and outputs work and how to do a basic truth table. So those kind of knowledge is a must to have, because otherwise it will be a bit hard for you to continue with this. So if you're not really good at those things, please visit those videos and watch them first and then come to this one, right? So in this video, we are going to discuss how to design the logic circuits, right? Based on the Boolean expressions given. At the same time, how to construct the Boolean expressions and the truth table if this logic circuit is given for you. So this is very important part for your final O-level exam essay question especially, right? Okay. So here they have given you some kind of a expression, right? So hope now these terms will be a bit common for you, right? So they have there's a dot. So what this dot means is it's an AND operation. This is not a multiplication. Please note that. And we have a bar, right? So we call as a negation of a, right? So this is like if a is like if your a input is 1, your negation will be 0, like with the NOT gate, right? And we have another input B. So we have actually 2 inputs for this, A and B. And you know, for 2 inputs, there will be 2 states, 2 to the power 2, right? That means 4 states will be there, right? And here it's A, this is not actually plus, this is the O operation. So A bar O B, right? And then this whole result, what you do is you do again a O operation with the B bar, right? So at once it be a bit confusing for you. So don't worry about this one too much, right? I will explain from the basics after the we have so many exercises to do. So from that you can understand well. But this one I'm using to teach something else, to how to draw all these kind of circuits using multimedia logic, right? So if you go to this page in your textbook, the page number 122, here they have told you to use multimedia logic software to draw all these logic circuits, because it's very uh, helpful for you to check your results and all these things. So first click this, right? I will put this link in the description box so you can check this. So here you will go to a page like this, and from here the setup kit, right? So you can download this one. It's not very huge one, it's 1.4 MB, and you have to get that installed. Okay. So after you install, when you type here in your search bar like this, you can go to that particular application. You have to click it and go to that application. So it will be looking like this. Okay, so this is the multimedia logic, right? So this one we are using to draw the circuits. Understood? So initially, if you don't see your palette, right? Here there's a small button. Can you see? You can click this and you can get this palette, right? So this palette, yes, first time it will be a bit hard for you to understand how to draw and all these things, but with the practice, it's really easy, right? So here, can you see there's something to select, like we have in the paint, you can select, right? And there's a wire here, right? I will tell how to use this practically, but just the introduction. And here you can see an AND gate, an OR gate. So XOR, don't worry about it too much. And here you have the invert or the NOT gate. So here we don't have NAND and NOR gates because you can easily construct them with the basic logic gates. And another important thing is like this LED bulb, right? So we are using this because then we can see the output. For example, if your input is A and B, inputs are A and B, and if A is 1 and B is 0, what is your output? You can nicely get that visible using this LED bulb. And then we use the switch to get these inputs, because on and off, 1 and zeros, we have to give, right? Okay. So before working, I'm very comfortable with going for the zoom mode, right? Then we can easily see this. Okay, so what we are going to do is basically we are going to just copy this same um, circuit, right, into our multimedia logic, because I want you to tell or teach how to draw this. Okay, so get this picture into your thing and then we are going to draw it. So I will use my other screen to look at this. So you open your textbook and do, then it is really easy for you to see this. Okay, so I'm looking at the diagram and draw. So if you have your textbook, please open it and see, then you can understand what we have. So here we have, I'm telling the easiest way to draw the circuit. Now, usually in the exam, you don't have any practical thing, but in your day-to-day work, like in your school work, what you can do is like when you have the expression, right? Please draw the circuit in the book itself first or the paper, right? Because in the exam, you have to do it on the paper, right? So you don't have any other tools. So first, look at the expression and draw the circuit, right? So for this one, I'm not trying that because we have the circuit already with us. And after you draw the circuit, right, then only try to put it here. Okay, then it is really easy, right? Because then you practice how to, in the exam, how to do it also. Because if you just try to do it directly on the multimedia logic software itself, then you will lose some practices in the real exam how to do, right? So first read the Boolean expression and put it to a diagram in your book, right? Draw your logical circuit and then try to copy that here. So in this one, you know that there are two inputs, A and B. I'm talking about the picture or the diagram in 120 page, right? So here there are two inputs, so have two switches, right? So I'm putting all the needed things first here, because in this one, there's a small like usability like thing. Now, if you press again, it's having another switch here, right? So if you want to get rid of this, you can write, um, see, when you click, it will have so many icons, right? So what you can do is, this is a selecting, you can select them, right? And if you want, you can do the cut thing, or you can delete like this. Understood? Okay. So that's why I'm getting all the necessary components to the diagram and then do this, because then it's very fast, right? So I want two switches because two inputs are there, and I can see not gate. So you select here and just click it. No drag and drop stuff, right? And then you have a O gate, and we have two OR gates, and we have a AND gate. And yeah, we have two NOT gates. Okay, so these are the things we need. And I told you we need a LED also for check our output. Okay, right. Then I'm going for the selecting. So I can select these things and nicely place them accordingly. Right. So based on the diagram, I'm looking at my diagram and I'm placing these components here and there. Right. So see now with the selecting, I can easily do it. If you do it with like you get one component and select and like that, it will take so much time. That's why I took all the elements needed and I select and I move it accordingly. Right. And I select this wire and I'm going to connect this. Right. So the first line is directly going to this. And then I have the input for the NOT gate. Right. And I will have this one to this. So these things you have to connect with the wire. And B input directly goes to here one, right? And the other one, I will move this a bit down. So it's easy for me. And I'm going to drag this here. Okay, and then I will connect these two as well. So you have to connect to the correct point, otherwise it's vanishing. And I'm going to fix the final thing. And so I can make it a bit more readable. So I have not connected these two. Okay. Yeah, so it's now, I just copy the same diagram what I have in my textbook, right? And then I'm going to add these expressions. Now I will tell you, now if you get the circuit like this, sometimes in the exam you get the circuit like this and they ask you to write the expression to how to do it. So there's something called text also, right? You can add nice text. So I will add all the text needed. Actually, for each gate, I will have an output text. So that is what in the exam also you have to really do it. If you get the diagram on the printed paper, write these expressions on your circuit itself, then you can easily get the um, Boolean expression. So I'm doing the other way now. They have actually given the Boolean expression for you, but I'm drawing the circuit and then I'm telling you how to get this back. Okay. So I have placed some text file inputs here and there, and I'm going to place it nicely with the select tool. Okay. So select, do it at once, then it's really, really easy. Then how to change the text? You go there and right click. Sorry, you go there and double click, and then it will ask you to change. So it's having A input and you have the B input, right? So here, what is the thing? I'm getting A and there's a NOT gate. So this is actually A bar, right? So A bar or the negation, actually we don't have this line on top, you cannot do it. You can easily do this one, okay? Like this. So A bar will be this one. You give the A input and with the NOT gate, it's becoming the negation of it, right? And here, what is the thing? Now you get, before that, we'll go for this one, yes? So you get A negation and the B as the input. And what is this? This is a O gate, right? So A bar, this plus symbol should be there. Actually, this is the O operation, right? O, B, okay? Yes. Then this input and the A again given to this. What is this thing? AND gate. You see D like a letter D, I told you. So this is AND gate. So you can easily tell A with the dot because this is AND operation, and you can easily have some bracket because like in maths, you know, it will tell what to do first, like kind of. So I'm putting a bracket. So these two will be happening as an AND operation. So this is my expression. So in the exam also write like this in each gate, then it's really easy. So here what happened? So you have B and there's a NOT gate, and this will become B negation or B bar. Okay. So what are the things here? Now this is what this is O gate. And what are the inputs you get? B bar and this one. So write this whole thing again. Right, with the plus symbol, because this is O gate, right? O, you have B bar. Okay. Now, if you go and see your expression, so it's the same thing, isn't it? Instead of this top the line, I have put a bar like this. So this is the same thing. So this is how, if the circuit is given for you, how to construct the Boolean expression. For each gate, write these outputs, then it's really, really easy for you. Okay, so this has some interesting thing also. Now, in the truth table, we put this the 4 states. Now, I told you there are 2 inputs and 4 states will be there, right? So 0, 0, 0, 1, 1, 0, and 1, 1. So these are the 4 states for A and B. Right? So there's a small like a run thing here. So you run it, and then you can see the output. See this one, if the A and B both are 0, switches are like off, then the output is 1. The bulb is having the light. So its bulb is switching on. So this is 1. So if I want, I can change this switch. Now A is having the input 1, right? So still output is 1. And if I want, I can do this back to 0, and I'm making only B as 1. The output is 0. Right? If I want, I can make both of them with the input 1, 1. So A is 1, B is 1. So output is also 1. So very easily you can check your truth table as well. So you can draw the circuit, you can get the expression, you can draw your truth table, and finally you can check your result also from this multimedia logic software. So that's the beauty of it. I have explained from the basics. Some students may have done these things before in grade 8, like, but I did from the beginning. So you should understand what really happens there. Okay. Okay. Now we are going to do the activity, right? Okay. This one, the first one is they are asking you to draw the circuits for the Boolean expressions given below and construct the related truth table. So I will do this as from the beginning, like how to draw this circuit, right? So this is a very easy one, right? We'll see. We'll take a new window and try this in our multimedia logic software. Okay. So first one is having A and B. There are 2 inputs. So I told you there are 2 inputs. Actually, it's better if you draw this in your paper and then do it. But I will directly do it here because then it's easy to share the screen and all these things. So here you have 2 inputs. So we should take 2 switches, right? Because A and B, right? Then first this A, then there's A dot B. So these two are separated with the OR gate. So we need a OR gate also here, right? So what about A dot B? So there it's an AND operation. So you have a AND gate also, right? And there usually we take this LED thing. So it's very easy for us to do this construction. Okay, so I will select this and I will move these things here and there. Okay, so first I have a plus symbol and A dot B like that. So first we'll take A dot B, right? So A dot B, that means A input and B, there will be a what? This AND gate, right? So I will connect these two, right? I will connect this to A dot B, that part, right? I'm doing. Okay. And with this result, so what is this? A dot B, right? So that one I'm connecting with A with the OR gate, right? So actually one input for this is A, right? And the other input is the actually output of this one. And then I finally connect with this LED bulb. So actually I can see my result. That's why I'm doing this for the truth table. Yes, I will make this bit more clear and nicer. Okay, so this is how I should draw. I will construct the uh, expression and show you. I told you for each of these gates, I'm putting this text, right? Yes. So this is A, this is B, right? And here A, B, this is a AND gate. So that means A dot B. Okay. So here I get the A and this one and I do an operation, right? So A is there and these two I'm doing as a operation. So same thing, whichever they have given. So you can check whether you have done it properly, right? Okay. So how to do the truth table? I will show you the truth table also for this. I told you there are two inputs, A and B. So 0, 0, 1, 1, 0, 1, 0, 1. This is the pattern you have to put the inputs, right? And A and B, right? So it's not the multiplication, but here you should know that both inputs should be 1, then only your output will become 1. So I told you, you can do a trick like a mathematical multiplication, but it's not the case. But as a like a shortcut, you can do it like 0, 0, 0, like 0, 1, 0, like that. Okay. So all the inputs should be 1 to get this as 1. Then what they do is they add this result with A. So some students don't need all these steps, right? But some will need. That's what I'm explaining from the scratch, right? So this one you have to add it with A. 0, 0. Like add it means like actually it's the operation, right? So 0, 0, it's 0. Because you know at least one input should become 0. 1, then only the output is 1. So here 1, 0. So just 1, 1, 1. So output is 1. This is the operation. Right? I told you operation like a plus you can think of 0 plus 0, 0 plus 0, 1 plus 0, 1 like that. But that's not actually plus, it's the operation. Understood? Now we'll check this result is correct or not. Now here we know if A is 1 only, you can get the 1 as the output. Can you see? A should be always 1. I will check this with our software. Here, now if I put 1 here, I told you run this and make it 1. Yes, your output is 1. And if you make B also 1, yes. But if the A is 0, in all cases, it is 0. See, very easily you can check your truth table. You can ensure that it's correct or wrong. Understood or not? Yes. Second one, we have A, right? And here it's an AND operation. And here is A, O, B, right? So very similar like the earlier one, we have two inputs, A and B. So 4 states will be there. And so here there are two inputs, right? So we'll have two switches. right? And we have a AND gate and a OR gate. Not very hard, right? And then we need to have this LED also. Okay, so I will place this. So first we'll take the brackets, right? So they are A, O, B, right? So A, O, B, first that is the thing, right? Okay, I will connect these with the wires A, O, B. Right? A, O, B, then this output should be connected with again A. Right? So I will use another wire. So A and this output should be connected with the AND gate. So I will add the text here A, B, and the output here and the final thing here. So here it's A, here it's B, right? And this one A and B with the OR gate. So in this one, we have A, this is AND operation, right? I will put brackets so it's more clear. So it's not that hard, isn't it? So this is how you can draw your circuit, and this is how actually you can get the expression also from the circuit. Okay, right? A and B, two states, 0, 0, 1, 1, 0, 1, 0, 1. So this is the same thing what we have been doing for up to now. And so here A, O, B. That means A or B means if at least one input is 1, then the output is 1. So here 1, 1, 1. So that's why we get 3 ones. So this result should be taken with A and do AND operation. AND means both inputs should be 1 to become the output to become 1. So here there is a 0, there's a 0, there's a 0. So here, so A, this one. So 0, 0, so 0, 0, 1, 0, 1, 1. Yes, your output will become 1. 1, 1. Your output is become 1, right? So you can do this and check your answers in according to this one. If A is 0, your output is 0. If this is 1, it's 1, right? So we'll check this one with our drawn circuit. So if A is 1, you run this. A is 1, A is always 1, then its output is 1. But if A is off, like if it's not on, in both those situations, the output is 0. So you can easily check your truth table. Okay. Yeah, third one. So here, the third one, right? We have A, B, C. Actually, there are 3 inputs, right? And we have operation, AND operation, AND operation, and there's a negation also. So not gate also you have to include. Understood? Okay. Okay, so I told you there are actually 3 inputs. And we'll take the LED as usual. and we have two AND operations and one operation and a negation as well. So I got all the circuits needed. You may not do like this with the practice I'm doing it, but if you first draw it slowly and then do it, I'm showing you how to get the final answer. Then you can check with your thing. So you have A and B, right? A, O, B, right? So like this, I'm connecting with the wire. A is there. A, O, B, right? And you have, we'll take the brackets first. A, O, B, A and C bar, right? So C bar, we'll create the C bar first. So this is the C, and if you get with the NOT gate, you will get C bar, right? C bar, right? And this one, A, I will take this one down here a bit. Yes. So A and this output C bar will have another circuit like this. So A, B, there is an operation, and A, C bar, we have a AND operation, and these two will do again have a AND operation. Understood? I'm not doing this naming and all. So we'll see the truth table. Yeah. So here A, B, C, there are three inputs. So I hope you remember 4 zeros, 4 1s, 2 zeros, 2 1s, 2 zeros, 2 1s, then 0 1 0 1 0 1 0 1 like that. So first A, O, B, A, O, B. So that means A and B you have to consider, and if at least one input is having 1, then you will have 1. So as from here you have all the ones there, so your output has 1. So for very brilliant students, all these steps are not needed, right? I'm explaining for average, right? And then we have A dot C bar. So C bar will do it separately. Then you understand it more clearly. C bar means negation of this. So 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0 like that. Okay. So this is a negation of it. So this and this you have to do AND operation. A, C bar, A and C bar. That means both inputs should become 1, then only this output will become 1. In all these cases, it's here. Yes, this is a 1 because both inputs should be 1, 1, 1. Got it? So you get these two columns filled up, and these two again you have to do AND operation. So AND operation, both inputs should become 1. Then only output is 1. Again, this scenario it's 1. This is 0. This scenario you have a 1. So only two scenarios you have 1, right? So that means one thing is only A is 1, other one is A and B is 1. Now we can run our circuit and very easily see this, right? All zeros, no. Yes, if A is 1, yes, bulb is switching. I told you the other occasion is A1, C1. Sorry, A1, B1. See, only that occasion you are getting this bulb lit up. If I make this, see, any of these occasions, the bulb is not switching. A should be 1 always to get a 1 output. Understood? So like that, you can check your status also, the answers. Okay, so in the second question, what they have asked you to do is write the Boolean expressions for the circuits given below, and you have to construct the truth table. So I have already drawn this circuit to my multimedia logic thing. But before that, we'll construct the truth table and see, right? So A and B, there are 2 inputs. So there will be actually 4 states. Right. So before that, yes, we'll do the expression. Right. I will open up the previously drawn circuits because I have already done that. Yeah. So this is the same circuit which is given in your textbook, isn't it? Yeah, this is already given. So here we have to first construct the Boolean expression. So we'll take the palette and we'll take this text and try to do it. Right. So here I will put it. Here I will put it. So in this one, actually, if you can see clearly, I have drawn as a 2 gates, right? Because we cannot directly do NAND. We have the AND gate and the NOT gate. So I'm putting the output here itself because that's the thing, right? Because then it's easier. And this one, I will put another output like this. Okay, so we have A and B, and here we have A and B. And what is this gate? This is a OR gate. A or B, right? And here we have A, B, and there's AND gate and the negation of it. AND one. So A, B, we have an AND operation and the negation. I told you with the bar I am putting it with the apostrophe like that. Yeah. So A and B, and there's a negation. So this one, it will take the input as these 2 and will do again an AND operation. So we have A like this. We have 2 inputs, right? And these 2 actually combines together with the AND operation. Understood? So this is the expression. We'll see how the truth table works. Okay, so this is the thing. A or B, A or B with the bar or the like negation thing. You can write in 2 different ways, no problems. And here, this is the thing. So here again the same story. A, B, 2 inputs 0, 0, 1, 1, 0, 1, 0, 1. And you have to first do this. This is a operation, right? At least 1 input should become 1, right? Then only we get this. And we get A dot B. That thing that is actually A and B. So you can do it. A and B, you have to check the both the inputs should become 1. That means only here it's the output having the 1. So the very brilliant students don't need all these steps, right? You can definitely skip this because in the exam you don't get marks for each of these columns. So if you can get the final answer, then that's it, right? And here for that one you get the negation of this. 0 become 1, 0 become 1, 0 become 1, 1 become 0. So this is actually the our NAND gate, right? And then this result and this one, you have to do AND operation. So both the inputs should become 1, then only this is becoming 1. So similarly, like the earlier one, you can try this in our circuit and see. I will do one more time for you to understand. So according to our truth table, when both are 0, the light is not switching. But if the B is 1, yes, light is switching. And if only A is 1, also the bulb is switching. But if the both are switching on, this is switch off. Understood? It's really, really easy. So this is the third B one we are going to try. So I have already drawn this, right? As according to the book. So nothing hard. So only this NAND one I am having two separately, other than the same thing, right? So I wrote the expressions in each gate. So this is a B negation. In this one, what happened is A and B, you get it, do the AND operation and get the negation of it. And these two will be taken here and we'll do the negation of the whole thing. Understood? So for this one, if you wrote this and this with a dot, but then you take the full negation of it. That's how the expression will come. Okay, we'll see the truth table. So you can try this. You can pause the video and try this. No harms, right? No hurries. Because you can try this and see. Okay. So again, A, B, two inputs, four states, right? I did A and B first, got the negation of it, and I got the B negation separately. So B negation is 0 become 1. 1 becomes 0. 0 become 1. 1 becomes 0. So that column also 2. And I get these two and do a what? There's a dot here, right? So that means AND operation. So AND operation means both the inputs should become 1. Then only output is 1. So in these two scenarios, it's 1. Then I'm taking the negation of this whole thing. 1 becomes 0, 0 become 1, 1 becomes 0, 0 become 1. Really, really easy if you do in this format, but if actually it's not time consuming, right? In the I also when I was doing the O levels, I did similar thing, because even you think, oh my god, I am adding so many columns unnecessary like that, but actually it's not adding much time, because if you are really practiced with this, you can quickly do it and without zero mistakes. That's the most important thing. Some students try to do this in their head and do mistakes. No point, right? We don't get the mark. So if you do with systematical way, yes, it has some more, but actually it's not taking time. Sometimes when you do it in your brain like it will take some unnoticeably, you take time. You don't have any output in your paper. But think now, while you're doing this, you did this column and you got a break kind of, suddenly there's something happen. Or you drank some water, or some disturbance happened, but still you can continue quickly because you have this thing in your paper. But if you do it in the head, sometimes if there's a sudden breaking, then again from the beginning we have to do. So that is there. So I'm very comfortable with this. So if you can skip, no worries, you can skip, but make sure you get the correct answers. Okay, next one. This one, right? We have 2 AND gate, 3 AND gates actually with a NOT gate. Right, I will open up my circuit. Yes, I have already drawn it. So A and ABC. So this is an AND gate, A dot B. This one I'm getting B and C, so B dot C. And this one, there's a negation of it. with the NOT gate, invert, right? So for this AND gate, I get this input and this input, and I'm doing a AND operation with a dot. Very easily, I can get my Boolean expression with this method, isn't it? If you write the each sub expressions near these gates, very easily you can get no mistakes. Okay, we'll see our truth table also. Right? Okay. So ABC, 3 inputs, right? Same way I'm putting this pattern, right? 4 zeros, 4 ones. 2 0, 2 ones, 2 0, 2 ones, 0 1 0, sorry, 0 1 0 1 0 1, like that I'm writing. And A dot B, that means A and B, right? A and B, that means both inputs should become 1, then only my outputs become 1. That means only this scenario, I'm getting 1s as my output. Then I'm taking the negation of it. 0 become 1, 0 become 1, like that. Only here 1 1 0 0. So this is a negation of this. Then I have to do B and C. B and C, B and C. So here I'm checking, here it should be 1. In here it should be 1. Only 2 inputs will have, 2 outputs will be 1. So I have this one, and I'm doing again AND operation. That means both inputs should become 1, right? So only one scenario is there where the output is becoming 1. So this is not hard, isn't it? Okay, we'll go for the next one as well. Yeah, here let me show you small thing when you're drawing the circuit. Here, can you see in this one, there are 3 inputs. So some students may feel hard how to draw this. You right click on it and there's something called properties. So from properties, you can select how many inputs you can go for the gate. When you get the gate, you cannot connect any inputs. If you have connected, they will give some error. So get the plain gate and right click and change the properties for the 3 or 4 inputs like that. Then easily you can have 3 inputs. So that's a small thing I want to add. Other than that, it's the same thing, right? So we have actually 3 AND gates, 1 OR gate. So A, B, we have BC, we have AC, we have. So all these things, we do a operation. Very simple, plus plus operation. So this is our Boolean expression. Let me show you the truth table also. Same story, ABC, 3 inputs, 8 out, 3 inputs, 8 states, right? So A dot B, B dot C, A dot C. So I did separately some AND operations, and finally I am doing it with the operation. So operation means at least if you have one input, the output will become 1. That's why these scenarios you have ones, so your output also having 1. Very easy, isn't it? Yeah, this one. Okay. So we have AND gate, NOT gate, and a OR gate. Very simple circuit, isn't it? Okay, so this is the equation. We have A, B, C. So here you have B and C with the AND operation, right? And there's a actually a NAND gate kind of, right? So there's a negation separately, B and C with the negation of the bar. And this input and A will be taken for this OR gate, right? A is there, OR gate, and then this output. Okay, we'll see the truth table. Yeah, so this one we have A, B, C, 3 inputs, right? 8 states. B and C, I did it, right? And then take the negation of it. 0 become 1, 0 become 1, 0 become 1, 1 becomes 0, like the negation happens. And I take this and A. I'm doing an operation. That means at least if one is there, then you have output as 1. So in this one 0, 0, so your output is 0. In all other scenarios, we have at least 1, 1. So that's how this is coming. Okay. Yeah, next one. Yeah, it's bit complicated because we have NAND gates, NOR gates, and again there is a NOT gate. Showing you the circuit again, but you can draw it definitely. I will show you the truth table. See my expression. Yes, it's a bit complicated. First you have A and B, and we take the negation of it because that is actually a NAND gate. And then we have A and B. We take the negation of that as well, right? And there's an operation. We get the operation and get the negation of the whole thing. Why? Because there's a NOR gate, right? So you get the O1 and we take the negation of this. Then finally we have a NOT gate. So that means the whole result again, you have to take the negation of it or the invert of it. That's why again full thing, I'm taking the negation. And please note there's a small interesting thing. If you have now whole thing, I'm taking negations 2 times, isn't it? So 2 things I'm getting, whole thing I'm getting negations. So then actually this negation to negation, it's like cancelling off and you can only consider this part. But please note, like you have to take the negation of the whole thing, right? If you take the negation of the whole thing 2 times, that means again it's the same expression, right? But I have done the full working to show you that, right? So we have A and B, right? We get it, we get the negation. And actually same thing we have to do operation. So same thing, right? So that means you get like this. And I take the negation of this whole thing. 1 becomes 0 like that. So I take the negation of that. And again, there's a NOT gate. So I have to take the negation of this result again. Now, if you see carefully, this and this, same thing, isn't it? That's what I told. If you take the negation of the whole expression 2 times, it's like cancelling off. You can take the expression itself. Understood? Okay, so that's the end of our part 3. Actually, there's another part. So hope you understood this, and this is very important for your final exam. So please practice these things, because in the final exam, there's a 1 step more, right? Because they will give a scenario. You have to read the scenario and construct the circuit. Then you have to get the expression, and then you have to do the truth tables, and also that's how the final questions will be. So hope you understood this thing. So if you haven't still subscribed my channel, please do subscribe, and please add comments. So I'm very happy to see your comments. Some students are saying they got A, they got good marks and all these things. So they really encourage me. So thank you very much. So we'll meet soon.